Hi, my name is Logan Nash and I'm an FTC alum of Team 18145 Men in Black Jacks. Today I'm going to go over how to tune Pedro pathing along with creating our paths with our reactive vector follower. Let's go ahead and get started. First, we do have a few prerequisites. It must be an omnidirectional drivetrain, so only a mecanum drive works on this right now. Later down the road, we may be adding implementations for swerve and tank drive. We do operate in radians and inches, and you must weigh your robot in kilograms. You can go ahead and add the weight of your robot in our follower constants class. Let's go ahead and get into tuning your localizer. In order to set your localizer, you would need to go into the pose updater class. There's going to be a little spot where it says your localizer. As of right now, it should be 3-wheel as your default. It's going to say 3-wheel localizer hardware map, and you can go ahead and change it to any 4 of these localizers that I'm showing you. First, we have drive encoders. All of your drive encoders must be connected, and they must match the name that you have on your device name. So let's say your left front motor, it should be like LF that matches based off of your config that you've set. Make sure you also reverse your encoders properly, because as you push your robot forward, all of your encoder ticks need to be counting up, or else your localization will be inaccurate. We have 2-wheel odometry, where you can set your you set your encoder poses, and you do have an IMU. You have the same thing with the forward and your strafe encoder, where you need to replace your encoder ports and reverse them, but make sure you set your encoder coordinates correctly. What we did is we have ours in millimeters, since we pulled it off our CAD, and transferred the millimeters over to inches. You can still set it in inches if you'd like, and it's very similar to how Roadrunner has their coordinates for odometry, where you do have your positive and negative plane. And for your IMU, make sure you have your logo facing direction and your USB facing direction set correctly, or else you will get inaccurate localization. Then we have 3-wheel odometry, which is the same as 2-wheel, except you have an extra pose that you do have to add, and you have an extra encoder that you do have to define. And we were thinking for compatibility that most teams will probably switch off Roadrunner for us if they are a little bit more experienced, so if they wanted to try something different. So we thought to add Roadrunner localizers and creating that sense of transferability. So we have our Roadrunner encoder and our Roadrunner localizer already built in, and we do have our transfer class. This is only available for 3-wheel odometry, but this process is the same for drive encoders and for 2-wheel odometry. This does run off of the depreciated 0.5.6 Roadrunner, so if you want to use this, make sure you do implement the 2 things I have on screen within your team code Gradle. We may look to add Roadrunner 1.0 localization later down the line to allow that transferability if enough teams would like to see that. And now, we do have video examples of what tuning your localizers does look like. On our left, we do have a video of us pulling our robot, so that's going to be tuning our forward localization. You pull it around 40 inches or so. I believe here we pulled ours around 32 inches, and it should give you an accurate value. It's going to be a decimal point in your thousandths, and that will be something you plug into your localizer. The video on the right is your turn ticks. You spin your robot 360 degrees, and it spits out another value in the thousandths. There is a lateral test that I don't have pictured here or a video here. It's the same process. You just move your robot to the right for 40 inches, and it will spit out lateral ticks to you. And now we'll move on to the automatic tuners. So there are 4 automatic tuners. Our first category is our velocity tuners. Pictured here is our forward velocity test, where the robot's going to move straight for around 40 inches and instantly stop, and it'll give you your X movement value that you can plug into your follower constants. If you don't like it at 40 inches, you can up the inches to something where you find a little bit more consistent. I know some teams, they use 72 inches while tuning. So if you do have the space that permits, I recommend doing 72 inches if you feel that 40 inches isn't consistent enough for you. Along with the forward test, we do have a lateral test where it runs to the right for 40 inches. Like I said, it's the same process. You can up the inches if you need it to be a little bit more consistent. Next is our zero power acceleration tuners. This tuning process allows us to factor in our slowing down process of the robot. So whenever the robot stops, there will be less drift accumulated within our paths. So on our left, we have our forward zero power acceleration tuner, where it's going to run at a maximum of 10 inches per second on your velocity. Once it reaches that 10 inches, it will start to slow down and track as it stops. And on our right is our lateral. It still runs the 10 inches per second. Once it reaches that, it goes ahead and stops. Your lateral will stop sooner than your forward, so that's why we see less movement on the video on the right compared to the video on the left. You can up your velocity if you need it to be a little bit more consistent. Some values that we used, not pictured in the videos, was around 30 inches per second or 20 inches per second, whatever you deem comfortable. And these values you will be able to plug into your follower constants. And now we move on to the fun part, which is manual tuning. You have 3 PIDs that you tune here, and you tune your centripetal force. To start off, our translational PID, our heading PID, and our drive PID will be tuned on back and forth, straight back and forth. So as you can see here on the video of our left, to tune translational PID, you just push your robot left and right, differing values. Tuning your large PID first. I recommend doing large PID first, so whenever your robot corrects within the certain amount of error that you defined, it'll be a smooth transition, because having that smooth transition will just allow your robot to kind of move a little bit more freely instead of jerking to one place to another. So your P value is probably going to be at around point X, which is in your tenths value, and your D value is going to be at 0.0x in your hundredths value. Make sure you avoid using integral. Integral in your PID testing includes a lot of variability, which adds up to a lot of inconsistencies and errors. So we've separated our PID. We have your P and your D in your large and your small PIDs. You have large and small integral and large and small feed forward. Adjust your feed forward separately. Don't add your feed forward onto your large and small PIDs, and avoid touching the integral unless you find it necessary. For your heading PID tuning, you're going to have a P value of 1 to 5. Our large PID, we use 1, and our small PID, we use 5, and our D value is around the same as our translational, where we see it in the hundredths value. Usually the numbers I found here were pretty consistent to the numbers we found at the little beginning of our tuner. Same thing as our translational. Avoid using your integral. I believe our feed forward value here was around 0.015. You can move your thousandths place up or down where you deem necessary. And here is our drive PID tuning. The footage for this did get lost, so I'll just explain how this works. Our drive PID tuning, to first start it, you have to set your zero power acceleration multiplier. The higher numbers are the faster you stop, but the more oscillations are introduced within your tuning. And having a lower zero power acceleration multiplier means slower stopping, but you'll experience less oscillations. So around the recommended value we've seen is 4. I believe going from 2 to 6 is probably the best range that you'll see. And whenever you're tuning your drive PID, make sure you have both your translational and your heading PID turned on. Same goes for your translational. You should only have your translational and your drive PID on. And for when you are tuning your heading PID, make sure you have your heading PID and your drive PID on. So when you're tuning your drive PID, you're going to see a P value roughly in your hundredths and thousandths place, and you're going to see a D value in your millionths place. And there's going to be a little bit of feed forward that you can tune. And now that brings us to our centripetal force correction, which is very, very easy and intuitive to tune. You're going to enable all of your PIDs on your dashboard, and you're going to observe how your robot moves compared to the curve as represented on the dashboard. If you find that your robot is correcting more towards the inside of the curve, go ahead and increase your centripetal force. And if it's more towards the outside, go ahead and decrease your centripetal force. And that's the end of the tuning process. The tuning process I've had is pretty easy and simple. And now we're going to move on to making paths. As we outlined in our prerequisites, we run in inches. So our coordinate plane runs from 0 to 144 both ways. Our blue left corner is 0, 0. And our right red corner is 144, 144. This is a little different than Roadrunner because Roadrunner has the middle line be 0, where it's negative and positive, which creates different poses. And how we combat that is, as you can see at the bottom part where we define our pose, we do have a negative number, but we add 72 to make that positive and allow that to cooperate with how we have our paths set. So poses you can define in 2 ways. You can define a pose with your heading and without your heading. If you don't define your heading will be at 0 degrees automatically. And if you want to set your heading, you can set it anywhere within 360 degrees. Moving on, we do have points. Points are very crucial to how our Bezier lines and Bezier curves work. Points are built from the poses that we've created, and there's 2 ways to initialize them. You can either initialize them from a pose that you call from a variable that you defined earlier, like our blue left side spike mark, or we can create our own as represented by the comma here, where we have 1 point and our second point. We can either use these for lines and curves and make sure that you define your point as Cartesian. And now we move on to our Bezier lines, where you're going to have 2 points. You're going to have your start point and your end point. This is just for your robot to move in a straight line. It's very similar to how Roadrunner has your forward, your back, left and right, how many inches that you define. Bezier curves is where it gets a little bit more complicated, where you have to have 3 or more points to create your Bezier curve. You can create your points in any which way. Where here in our Bezier curve, we have a point calling off our initial goal pose. We have a point that we've created all on our own, and then we have a point where we get our first cycle stack pose, get X. We can get the Y of our pose as well. If we do find a little bit of inconsistencies in our poses on our get X and get Y, we can always add and subtract it by subtle amounts to make sure we get there. If you find that your curve isn't as consistent, I recommend adding more control points to your curve so it'll be able to match something you were going for a little bit better. Um, Something I didn't speak about earlier. Whenever you create lines or curves, you don't set your heading. This is where you set your heading instead. After each line and curve that you create, you often set a constant heading interpolation, which is just going to be which will just be the way you set your heading and the curve on the line or curves that you make. You can get your headings from the pose that you want, or you can create your own. Either or is up to you. I just recommend pulling from a pose that you made. And now we will get into path chains. Make sure you define your path chain as variables to start before you start building your path builder. Paths must be built in a function. So we have a public void function here where it's our first cycle stack. It's in our build paths void function that we're able to call in our start phase. In our initialization, we also do have our follower and our starting pose initialized here, so we're able to use our path follower. And now we'll get into holding points. This is a function we made where our follower can hold a point. So what we do here is we get the last control point from either a curve or a line, and we're able to hold our end tangent and hold our heading. So comparable to how Don't Blink was in the 2023 Power Play World Championship, where they couldn't be pushed. Hold point works the same as how theirs worked, where a robot, you could push the robot and it would recorrect and the heading wouldn't be able to change whatsoever. Along with this, that would be the end of our auto enhancements. Our tele-op advancements, we do have smoother turning, where we initialize our drive vecting and our heading vector, where we use our centripetal force correction that we tuned in our curving back and forth within one of our manual tuning. We use that to create smoother turning. As we turn currently, our robot swings out wide and then goes tight and recorrects. Centripetal force correction actually eliminates that and creates a smoother turn overall. Thank you so much for your time. Thank you for listening to this video. I want to give a special thanks to Scott Spots this season. Thank you to Jack, Ani, Aaron, Yoyi, and Harrison for all their hard work this season. None of this would be possible without them. I will say, if you are interested, we have a GitHub pages in the works right now that will explain more functions that we do use. And we are also working on a path simulator that should release sometime before next season. Thank you so much for watching this video. If you do have any questions, my Discord will be in the description below. Feel free to reach out, send videos of what you think your Pedro pathing looks like, send your achievements and issues. I'll be happy to reply to them. Thank you so much and have a great night.